Hi, this is King of Review. Here we need to expand 2x minus y to the fourth power, and we need to find the coefficient of the x squared times y squared term. Now we could multiply 2x minus y by itself 4 times, but it would be very easy to make a small mistake somewhere. Instead, we could use what's called the binomial theorem, a shortcut for expanding binomials, like this one with 2 terms, when they're raised to a certain power. And my favorite way to use the binomial theorem is to use a method called Pascal's triangle. Pascal's triangle is a triangle of numbers. It starts with 1. On the next row it has 2 1s, so that already we're making a triangle. The next row starts with 1 and ends with 1 again, but in the middle we have a term where we add the 2 numbers above it. 1 plus 1 gives us 2. And every line after that goes the same way. We start with 1. For terms in the middle, we add the 2 numbers above. 1 plus 2 gives us 3, 2 plus 1 gives us 3, and then we end with 1. The next line then would start with 1, 1 plus 3 gives us 4, 3 plus 3 is 6, 3 plus 1 is 4, and we end with a 1. These numbers all represent coefficients of the terms that we get when we expand a binomial. The top row is the coefficient when we raise something to the 0th power, the next row raised to the first power, the next row to the second power, then the third power, and then the fourth power. And the fourth power is what we want in our expansion. So we're going to use the coefficients in the fifth row, the row for the fourth power, in Pascal's triangle. If we expanded this binomial, we would get 5 terms. The first term would have coefficient 1, the next would have coefficient 4, the third term would have coefficient 6, then a term with coefficient 1, and lastly a term with coefficient 1. 1, 4, 6, 4, 1. The 5 numbers in Pascal's triangle on the fourth power row. And these would all be added together. So we have the coefficients, but now we need to fill in the rest of the terms. And those come from the actual numbers or variables in our binomial. We'll start with the first one, 2x. In the first term, we'll have 2x raised to the fourth power, since that's the power we're raising our binomial to. The next term goes down by 1, 2x to the third, then 2x squared, 2x to the first, and 2x to the 0 power. For the second part of our binomial, negative y, we go in reverse. We start with negative y to the 0, then we go up to negative y to the first, then negative y to the second, negative y to the third, and negative y to the fourth for our final term. Now, this is the entire expansion for 2x minus y to the fourth power. I want to focus on the term where we will have x to the second times y to the second. And that's clearly this term in the middle where we have both of our variables squared. So let's see if we can work with this term here. This term is 6 times, now we can distribute the squared to both terms in parentheses, so we'll have 2 squared times x squared. And since a negative times a negative is a positive, this last piece just turns into y squared. So that's 6 times 4 times x squared y squared. 6 times 4 is 24. So we've just shown that the coefficient of x squared y squared is 24. So our answer is D. Thanks for watching.